Hi there and welcome to the screencast. Tonight I'm going to be solving the review problems for Monday's quiz on quadratics. Okay, in the first few problems here I'm asked to factor. So I'm going to first of all look for a GCF. So 3b squared minus 24b, I notice that I can divide out a 3 and I can also divide out a b. So I'm going to go ahead and do that. So I bring out a 3b and that leaves me with b minus 8. Okay, number 2, also a GCF of p. So I'm going to bring out the p. And now I need two numbers that multiply to be 10 and add up to negative 3. That would be negative 5 and positive 2. And that is my factored form. First few words in tonight's sentence are the life. Alright, moving on. Okay, in this one I can also see that there is a common factor of x, so I'm going to factor that out. And now I need two numbers that multiply to be negative 10 and add up to positive 5. And I don't know that there are any. Let's see, 2 and 5, no. 1 and 10, no. So it looks like this is about as far as you can go with factoring. Okay, and the next one, I'm going to use the technique that I showed you where the first thing you do is take off the 5, multiply the 4 by the 5. Now you factor this, so I get, let's see, x plus 5, x minus 4. Then you take the 5, you put it back in front of the x, and you factor out any common factor and eliminate it. So 5x plus 5, I can remove a 5, and that is my factored form. Alright, next few words are you save. Alright, now I'm asked to solve some quadratic equations. So first one, I'm going to move every term over to the left. I'm either going to solve by factoring or using the quadratic formula. So I'm going to add 50 to both sides, subtract 15x from both sides. That causes the right side to become x squared, or 0, and the left side to be x squared minus 15x plus 50. Now at this point I could use the quadratic formula, but if I look at it I think I can factor this, and yes I can. So I need two numbers that multiply to be positive 15 add up to negative 15. That would be x minus 5 and x minus 10. And now since it's an equation, the solution is going to be the solutions to each of these little equations. And that gives me x equals 5 or x equals 10. Alright, next one, I'm going to do the same thing. I'm going to add 7 to both sides. And I get r squared minus 8r plus 7 equals 0. Then I'm going to factor. And that's going to give me a solution of r equals 7 or r equals 1. Next few words in the sentence are may be. Alright, number 8. I'm also going to move everything over to the left and then either factor or use the quadratic formula. Alright, I think I can factor this one, so I'm going to go ahead and do that. And that gives me a solution of -3. Alright, number 9. This one, I see there's no linear term, so I'm going to be solving it by taking square roots. So to do that, I need to get the a squared on the left side of the equation all by itself. And then I'm going to divide by -5, and I get a squared equals 3. And now I do plus minus square root of 3, and that gives me a equals plus or minus radical 3. Alright, just a few to go here. Let's see, this one also going to solve by taking square root, so I need to isolate the n squared on the left side of the equation. I get n squared equals 1. Do plus minus square root of both sides. I get n equals plus or minus 1. I'll have to pause here while I take a phone call. Alright, sorry about that. I had to take a call from my wife to discuss what we're doing tonight. Okay, number 11. Alright, so I think I'm probably going to try the quadratic formula on this one because I see there's a leading coefficient of greater than 1, and that means the p squared term. So I move the 5p over to the left, and now I'm going to use the quadratic formula. So my a value would be 2, my b is 5, and my c is going to be -25. So I'm going to fill in the template for the formula. And then I'm going to fill in the numbers after that. So now when I fill in 2, 5, and -25, let's see, b goes there, a goes there, b goes there, and a goes there, and c goes there. Oops. Forgot the a. Okay, so what does that give me? It gives me -5 plus or minus square root of 25 minus -200 all over 4. And that 25 minus -200 is 25 plus 200. So I'm going to get -25 or -5 plus or minus square root of 225 over 4. And the square root of 225 is 15. So I can do -5 plus or minus 15 over 4. So now I have two possible solutions. The one would be -5 plus 15 over 4. The other would be -5 minus 15 over 4. -5 plus 15 over 4 is 10/4 or 5/2. -5 minus 15 over 4 is -20/4 or -5. So those are my two solutions. Alright, was that problem 11? Yes, it was. Alright, one more to go. No, two more to go. Two more to go. Okay. So this one I'm also going to be solving using the quadratic formula. So I'm going to move everything to the left. Doing that. Okay, so A is 5, B is 5, and C is -2. So when I substitute those numbers into the formula, I get -5 plus minus square root of 5 squared minus 4 times 5 times -2 all over 10. And that's -5 plus or minus square root of 25 plus what? 40 over 10. And that's -5 plus or minus the square root of 65 over 10. And let's see, 65 is 5 times 13. There are no perfect squares in 65. So that means I'm finished and I got my solution. Can't go any farther. Alright, and the final one. Hopefully I have enough room for it. I'm going to add 5 to both sides. And that gives me 5x squared minus x plus 5 equals 0. Now I'm going to try the quadratic formula. So my A is 5. B is -1, and C is 5. So let's see if I can squeeze my work in here. Okay, so I would have -1 plus or minus square root of -1 squared minus 4 times 5 times 5 all over 10. So that's 1 plus or minus, now this ends up being 1 minus 100. 4 times 5 times 5 is 100. So 1 minus 100 is -99 over 10. Okay, and that square root of -99 can be simplified. It happens to be 9 times 11. And you can take the square root of 9. Or if you were doing what I showed you the other day, you would do that and rewrite 99 as 3 squared times 11. Okay, which is going to give you 3 root 11. Okay, so this becomes 1 plus or minus, and then it's going to be 3i root 11 because of the negative under the radical, all divided by 10. And that would be my solution. And the final few words in tonight's sentence are your own. Alright, hope somebody watched this, and we will see you on Monday. Cheers.